Hello, fellow Mythrunians. It is once again that time of week when we goof around with code and stuff, and as is lately mess with rivers. Um, so I'm still doing that. It's probably going to take me the rest of the month, and I'll get into a little bit about why. Before we get started, let me thank my patrons. Thanks, guys. On the dark days, you really helped me make it through. So, and even those of you who can't contribute, if you can just spread the word around about the project and the live streams and things, that'd be great. All right, without further ado, let's get started. So, as we recall, last week I was messing with rivers, and we're going to continue messing with rivers today. I kind of wanted to go over some of the stuff that I got accomplished over the week. So let's mess with that. I think we're good to go here. So let's run the mapper tool. We're going to look around in there again like normal. That's where I've been spending a lot of my time lately. Come on, mapper tool, you can do it. Okay. So there's our standard seed 1, 2, 3 world that I mess with because I'm really familiar with the terrain. One of the things that we didn't have going for us last time was when we were doing rivers, we were basically plotting them until they hit sea level, which isn't necessarily the smartest thing to do. Like you see this little guy here, technically that area of water is below sea level, and if you had a river coming from all the way down here, you don't really want it to stop there. It doesn't make sense. So one of the things I had to get working was the region support. And basically what that does, I'm going to do this and then hit, there's a bug in the mapper tool that with custom fractals it doesn't always update the tiles from far away. So we'll get that to update while I'm talking. So what it does is it goes through, for a particular tile, it goes through and finds all of the water that's deep enough to be considered, navigable water, and builds a region out of that that's a body of water, and does the same thing for the land. I can point the same things to like trees and areas of desert and so on, but right now we're just distinguishing land from water, and I will go ahead and render that. If we go over to regions and say draw regions true, and we should be able to see, yep. So there's the regions that it detected, bodies of land. It gives each one of these sort of a unique color, and sometimes the colors don't show up very well because this is like a light brown color. But it knows where all the bodies of water are. And this is where I wanted to start talking about the trouble with these tiles. This is a really big tile. This is 16 kilometers square. 16 kilometers this way, 16 kilometers this way. And mostly, like, as a gamer, you wouldn't so if you started in this tile, you wouldn't venture very far out, not for a long time. But the game world generation needs to generate out a while. One thing you come up with as a problem, let's say, here I'm going to flip over to a different screen for a second. So let's say we were just looking at this tile, and we detected this body of water up here, which is, if you can see, the landmass makes that look separate. I don't know if we actually have it separate on the, this is the same rough area. Yeah, it would have been separate. But, on its own, this looks like a separate body of water, this looks like a separate body of water, this looks like a separate body of water. These, when we deal with things at a purely tile level, that's the best we do. And even as we go, like if we hit this tile, we'd say, oh, these two bodies join. And that's kind of what the generation does. It says, okay, this is a region, this body of water is a region, and oh, they are really the same world region. But if we continue on, just like we see in this, not only did this body of water turn out to be this, match this one, but this body of water actually turns out to be the same body of water as this over here, and this body of water turns out to be the same body of water as this up here. These are things we did not know just looking at this tile. So there's a sort of propagation that happens where when we're looking at one tile, we check the neighbors for their regions, and if we find that they're matching, then we recheck this one and all of its neighbors and so on, so that if we had detected this and detected this and detected this and then came through and detected this, oh, these are the same regions, we would go back and fix this one too. And so then from a world generation perspective, I need to decide how big of a net I cast. 3 by 3 is probably not enough because we have some really big continents over here that actually amount to smaller levels of tile. When I have this screen up like this, I can't see the chat. There we go. Yeah, it is. It's crazy how big it actually is, and it's a competing thing because I want the world to be vast in the sense that there's always something over the horizon to explore, but then once we get all that working, I have to make it so that it's interesting locally too, because you don't necessarily have to walk a very far way to get interesting content. But I got to get the far stuff working first because, if there's a town here and there's a town way over here, chances are these people have heard of this town, and so if I ever do, in-world lore, generated lore, these citizens might know something about that town or hear a rumor about that town, that kind of thing. So I need to know what kind of stuff is around. But, because of that, then I need to decide, how big of a net I cast. And probably, based on this, 5 by 5 is probably what I'm going to end up dealing with. So you'd be centered on this, and then whatever tile you're generating, the world would need to make sure that there's a 5 by 5 area, at least plotted out for regions, and rivers get even worse, and I'm going to talk about that in a minute. But definitely for regions. So there's another problem that comes here. So one of the sort of implicit goals, let me maybe make a new page, Control Enter, there we go. My goals is that a seed equals a world. So if you put in seed 1, 2, 3, and I put in seed 1, 2, 3, we are going to get the same world generated no matter where we go, what we do. Currently that's true, right? Because the terrain is really very locally generated. At any given point, I can generate a, I can tell you what the terrain level is and so on and so forth. And so if you or I use the same seed, we're going to get the same world. Even if we walked 50 miles east, we're going to get the same world. When we start to get into these larger area nets to cast to do generation, we come up with a problem with that, though. And it'll be more apparent with the rivers and even more apparent with the towns. But let's use it on a small scale. And let's say we're back at this tile here where I've detected this body of water and I've detected this body of water. And let's say I didn't do any more searching than that. And so the game generated that. He said, oh, I found this body of water. Let me name that, the Eastern Sea. And I found this body of water, and let me name that one the Western Sea. But then as you explore, if a player starts heading east, and then these other regions start to fill in, and then the game world goes, oh wait, the Eastern Sea and the Western Sea are actually the same body of water. So that's actually a solvable problem in a sense, because chances are local people would have a local name for this body of water, and it might be different than this body of water. These guys might not actually know that these are the same. I mean, in here it is, but for big continents like this, any people living in this area here would call this, the Western Ocean, and this one the Eastern Ocean. They might not know that they actually connect if you go far enough out. And that's fine. You can work around that, and because everything's still relatively locally generated, it doesn't matter if I head east and you head north and we eventually meet, somewhere way up here, the names and all that generation is going to be the same. And even though you approached it this way and I approached it this way, all the bodies of water will be named the same because they were still named locally, and so on. It gets trickier when rivers will generate across tiles. And I'll talk about that maybe a little bit. And so it turns out to be impossible. And so let me just put that down. Seed equals world from any direction, any exploration order. Impossible. So let me real briefly talk about that. Oh wait, I'm in the wrong thing. So if I'm over here, let's actually get rid of the regions for a second. And bring back, let me show you, actually let's show rivers real quick, okay? Talk about that. No. Let me continue on this discussion. I don't want to flip around too much. So let's take the small case again where I generate rivers in this tile, and one of the rivers is going to cross into this other tile back here. And maybe the river generates up in the mountains here where the spawn position is. Let's pretend that. Okay, let's say the river generates where the spawn, it comes down into this tile and then turns around and comes back into this tile. So we can't just generate rivers in the tile, and we can't just propagate them to the neighbors. We also have to bring them back, and anything that generated here are back. So you end up with this case where we probably have to take a group of these quads and generate all the rivers at once. We start with here. There are other ways to do it. You could cut these guys in half, and you could say, well, I'm just going to generate the rivers from here that might flow into here, and I'll generate the rivers here, and whenever they cross the boundary, we'll just make sure that we're calculating all these together. The reason is because if I start with a river here and I come into here, I've created a condition where another river might join that river, right? But if I came here, if I was doing this tile first, this river might flow up into here, and then that river might have joined that river. So it becomes very order dependent. And in this case, it doesn't really matter because we're probably going to always generate things in the same order. But there's a tile way up here, whereas if you came at it from the east and I came at it from the south, it might end up generating completely different rivers. Now we hope that mostly no, because river generation is infrequent. I mean, we generate plenty of streams and rivers, don't get me wrong, but it's infrequent enough that they're unlikely to create radically different output, but it still would be different. So effectively, rivers make it impossible. And that's, the only other option would be to always generate a section of the world bigger than the longest river you'd ever expect. So this is, again, probably 5 by 5 I'd have to generate, because this continent, imagine 5 by 5 might encompass the whole thing. But in order to maintain that sort of exploration independent generation, I would have to then, if the player started heading east and I needed to generate these squares, I'd need to generate all of these squares around, because otherwise what happens is, player comes this way, this way, this way, this way, this way, this way, and then north, 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 and we're generating entire new 5 by 5 quads, 5 by 5 quads, 5 by 5 quads. And then we come back down to this area. Now we're starting to influence these, but we're generating these first, and they're infiltrating this and not the other way around. So ultimately, I just decided that particular goal is impossible. I'm going to do the best I can, but for a given world, your starting position will be the same as long as you use the same seed. But if one player heads west and the other player heads east, there may be slightly different outcomes. Towns may be in different places. Rivers may slightly change, and so on. So that maybe creates some interesting variation, but it's just unfortunate, because it would have been nice to say, oh, if you play world seed 1, 2, 3, you'll see this. But it actually turns out if you play world seed 1, 2, 3 and you head east first before heading west, that kind of thing, it might end up being like that. So let's talk about what I did with the bodies of water, and we might, if you don't know what cellular automata is, we're going to get into a little bit of that too, and I'm going to give a nice explainer for that. So one of the things, let me put the rivers up just to have something visual to look at while I talk. And so, when we dealt with this last week, we were trying to, make the rivers kind of head to the ocean. And I think I dealt with a little bit with the sea costs, right? Where I pre-map out all, so I'll explain what the coloring is later. But these are pretty decent looking rivers, and they're maybe about as good as I can get. And I'll talk about that in a minute. But these colors are red and pink and orange are places where the river goes uphill. And that's bad, but we'll talk about how bad that is in a minute. But in order for the know that the river flows to the ocean, I need to know sort of the best path to the ocean. And to do that, I calculated a reverse cost from the ocean using cellular automata. And let's get rid of the rivers and go back to sea costs. I think I can just draw costs. Draw costs. Yeah, draw costs. I think this is going to make big, ugly, spiky things. Yeah, so that's just like huge. So let's shrink those down for a second because I have the cost multiplier set super high. And I'll explain what the cost multiplier is too. So this might be a refresher. I think I had a little bit about this last time. But the idea being that as you get farther from the ocean, these costs go up. And if you had to come down a hill, they go up even higher, which is why there's these red, spiky areas. In fact, I can show what the pink is. The pink is the straight number of steps we took to get to a particular point, and the red is the cost of potentially having to have had the river flow uphill. So these costs are high because this is a little valley here, and so for the river to make it to the ocean, it would have had to go uphill in either of these directions, or this is longer and so on. But let me show sort of the delta, because we know that at a given point, we know the number of steps. We can actually just visualize the deltas between those things. Draw cost deltas, do not draw costs, and so on. Yeah, so this will just show where things are extra expensive. Essentially, anywhere that this is red, the path to the ocean has to go uphill somewhere. And the longer the red spike, the more uphill it had to go to get to the ocean. So these guys, flow mostly straight to the ocean, whereas these had to go uphill to get to the ocean somewhere. But Paul, how do you calculate these? Well, that would be cellular automata. So let's, I think I have a way of explaining this. So let me leave this up for now and come over here. So I've got like a map loaded in the background of a spreadsheet, which is a cool trick I learned today. So essentially, if we imagine that these are the 128 meter samples, I actually don't know what the scale is. Essentially, for everywhere that's water, you put a 0. The distance to there is 0, right? Yeah, I love them too. It's like basically this is the same as the way lighting propagation is done in Block World games. So basically, everywhere there's just ocean on your sample location, you put 0, and then wherever you seed there's a sort of queue of pending cells to deal with. And so first what we do is we go through the whole array, the whole spreadsheet, and we say anywhere that we are on land but we border some kind of ocean, right, or body of water, we'll put a 1 there. We're distance 1. And we add that to a queue to say, I'm going to come back and evaluate this in a second. And so we do that again here. That gets put into a queue to evaluate again. Same with this one, we check the neighbors. And so you end up with all of these little guys, that say they're one distance away from the ocean. And because we queued each of these up in a queue, we pull each of those off one at a time. And we look at all of their neighbors and we say, we want to give, the next higher score. Let's just deal with counts for a second, the distance, direct distance. I want to give the next higher score to any neighbors where that is the lowest value. And so from this one, we would want to give 2 to all of our neighbors. But these neighbors already have less than 2, so we'll end up just putting 2 here and here and here. And we come to this guy, 1. He wants to put 2 in all of these guys, but he only has to do it in 1. And so we basically, each of these we pull off the queue, and we end up, with something like this. Where it gets interesting, though, is when you start to get different values. So here we come up, this would be 3, we calculate those, but now we started to go downhill, and so we end up with increased costs, because if we're going downhill away from the ocean, that meant we had to go uphill to get back to the ocean. And so these start to get quite high. Maybe we've detected that that's a score of 8, and this then becomes 16, and so on. And perhaps this is 32. And so if we found that there was a better path, so these chances are these are about the same, because we're still going up that hill, right? Oh, this should have been a 32. But let's say that this is flattened out, and so this one, as we did with this, you get 3, 3, 3, but this one maybe it's not so bad. So it's still flat, so we get a 4 there. And this one goes downhill, but only a little bit. And so now, when we go to plot this 8, that 8 is flat to these guys maybe, and so certainly flat to this one. So he's only going to want to give 9 to that one, and so now we've created a better path, and then this becomes probably something like 15. And so now you start to see that there's a path that went around there, and so from any point here we could then follow the lowest back to the start. I don't know if that makes sense, but basically you do that for the whole map, and you end up with something like this where the red values are the scores. And like I said here, initially I just started off with straight distance, like this is how far away we are, but then we dealt with the going downhill part. And in this case, we're tracking both. The path we took, the straight 1 step, 1 step, 1 step, 1 step, 1, 2, 3, 4, 5, 6, 7, 8, 9, and also the extra costs. And so by showing this, I'm showing the delta between those two values. And so any of these cases where it's red, our cost was higher than the distance it took to get there, which means we had to go uphill to get back out. So that's cellular automata used to calculate the flow. And we can visualize this in a different way too, which is for every one of these sample points, we can have it draw a line to whatever the lowest neighbor is, and that will let us see the flow of the land itself. It's kind of wild. Oh, there's a threshold that I added. I'll take that out and I'll show you what it means, and I'll add it back again. Filter threshold. Cost filter threshold is used. Let's just say 0. I think that's the one. Let's see. That might actually be the opposite of what I want. Oh. Yeah. So let's just take that out for a second. Oh, it's down here too. Okay, so this should show everything. Yeah. So we kind of see how the so we didn't give very high costs for going downhill, and because at this particular location it is so far around to get to the ocean, it actually was cheaper to go over the hill. We can affect that with that cost multiplier that I talked about, that I set back to 1. If I set this up to 100, so let's get a good look at, actually I'll take a screenshot. So we'll take a screenshot of that, set that back to 100. So that makes it more expensive to go uphill, so it's going to prefer to go around mountains. And I don't know if you can see, but it actually moved these guys up the hill a bit. And so if we check, oops, oh, I didn't do this separate, I didn't do a screenshot again. Okay, there we go. So yeah, so you see right here, these guys were willing to go over the mountain to get to the ocean. And then when we changed that cost, we made that cost more, then now these guys would rather go this way. And there's a certain amount of cost where it doesn't matter, because it's always going to be so much cheaper to go this way no matter what cost you give. I mean, unless you make it physically impossible to go uphill. And we'll see why that's not a great idea in a minute. But so this is sort of the line. If you see this blank area here, that's the line, the cutoff line, where things are cheaper to go flow all the way over here than it is to go over the mountain. And so with this, you get like a nice picture where you can see from any given point, like from this point here, I follow this kind of like a maze, and I can come down here, follow this route here, follow this all the way, and eventually I will find my way to the ocean. That was the cheapest path to the ocean from that particular point that I started on. Now, this seems really cool, and you're like, oh, well, that's nice, because then we always know how to flow those rivers to the ocean. And so let's like put this other goal, which is to make rivers behave physically correct without cheating. Okay, so rivers would always flow downhill, and maybe we have to make them, you know, flow longer around a place, carve a little ground, and so on. But there turns out to be a problem with that. So let's say we don't want to allow any cheating at all. How far inland could we get and make rivers that never cheat? And that was that threshold I'd started with. So if I put that back, where'd it go? There it is. Okay, so if filter threshold is 0, put them back. So that means if the cost is ever greater than the distance, then we will not take that path, and which means that everything flows downhill. And we read up from the ocean. So essentially, if you only wanted rivers to flow downhill and you wanted them to reach the ocean, these are the only sort of rivers you could have, the only places you could have a river. Everything else would have to go uphill to get out. So then you say, well, I want to cheat just a little bit. Maybe it's okay to carve through 1 extra meter of a hill or 2 extra meters of a hill. So let's see what 1 extra meter of a hill looks like. Yeah, so we got maybe a little farther. Let me take a screenshot of this, and we'll bump this up to 10. We're allowed 10 meters uphill travel. Yeah, so with 10 meters uphill travel, we get pretty far inland. We'll take a screenshot, and I'll show you the difference. So yeah, so see if we want to like let the rivers cheat by as much as 10 meters, we can do that. But this doesn't really facilitate my goal of wanting rivers that, potentially stretch across continents. I mean, we'd get some cool rivers down here, but you see this big land mass over here, and it would be really nice if a river, yeah, there will be, so that's what happens when a river can't go any further. If we've decided that whatever threshold we have, we don't allow the river to cheat, it'll stop and make a river or a pond or lake depending on its size. But what I want is some rivers that go a long time. So I want to allow a little cheating but not too much cheating, and how much is too much cheating, and so on. And so we get into this. Let me see if I can recenter this over this continent so we can see what that would look like. I think I have to go here. Let's add, what is it? Grid size times 3. Okay, that'll do a bunch of stuff. And then we have to refresh the rivers. Let's refresh sea costs. Sea costs actually might do bad things. So yeah, we detected the regions. Okay, we moved over our grid. Okay, so we did our costs again. But you see, we don't make it very far inland at all for these particular flows. We would have to be quite a bit more aggressive in allowing cheating if we wanted to go inland at all. And one of the reasons I want long rivers is so that if you had, so that you can have the sort of classic, if you imagine, a river flowing from here, you have a classic mining town in the mountains. How does it get its product to the world? It's got a big long river that comes out. And so you have the sort of classic setup where you have a town that forms at the base of the mountain, potentially little villages along the way, to supply river travel, and then a big town seaport here at the ocean. That would be the goal, to have that kind of stuff randomly generate. And so we end up having to cheat quite a bit. And again, and this the other thing is, this is just approximation, right? So we're only sampling every 128 meters, which is super long. Let's see what rivers this would have generated if we had generated, excuse me, rivers. Let's turn off, or draw rivers is true. Draw cost rates, draw rates. Oh, I'm drawing flow here. That's what it is. Okay, so let's turn off flow. So you guys are going to get to see something I haven't looked at yet, which is what the rivers generate if I'm centered over this continent. And we'll do that in a second after these. So we'll get rid of that and let rivers generate again. Sometimes this takes a while. So we go. Yeah, I mean what the cellular automata does is let me instantly know what the gradient flow would be, right? If I don't cheat, I basically only take lowest distance. I ignore the costs for the most part, or I only take the lowest distance where the cost is the same as the lowest distance, and then I always will flow down the gradient. And yeah, yeah, that's one option, and I'll talk about that too. Wow, this is crazy. Look at that. That's cool. See, this is probably a little too aggressive. so I mean, the cellular automata is it allows me to, with one pass, to calculate all that. I can tell you any river's pure gradient flow. I can tell you whether I let it cheat by 1 meter or whatever. I don't have to calculate each river separately because each one of those river propagations takes a long time. Once I have all of the costs done, at any given point I can tell you, oh, if we had a river here, it would flow in this direction if it wanted to get to the ocean. Simulating submersion. Yeah, so indeed, I mean, that's already what I do. Wow, this looks really cool. And again, this looks like a super lot of rivers, but when you're actually in here, this is. But if you eliminated all the red ones, okay. Before I get too far ahead of myself, you've asked a question, and I am going to get there. So let's get there a little quicker. Let me put the grid back where it's supposed to go, over near our spawn position, because that's where I'm used to playing. And the way I have this set up right now is, even though this is not integrated into Mythruna, I do save the rivers out so that if I load that world into Mythruna, it will sort of put the rivers in. And let's generate the rivers again. That view of the big continent was actually quite encouraging in some ways. I'll talk about why that is true in a second. So, yeah, so here's the rivers. My favorite one to play with is this one up here, because it's really long and it has relatively few places it had to cheat. It starts out in the mountains up here, cheats a little, cheats a lot, comes down, cheats a little, cheats a little, cheats a little, cheats a little, cheats a lot. But again, this is an area where it might have found a better path. The chance that because I'm sampling at 128 meters, means that there might have been a better path. I'm just skipping it. But once it gets down here, it's pretty much all downhill, which is a nice river. That's a day's worth of travel. I've actually 2 days worth of travel. So let me close this for a second. We've got these rivers saved. I want to show you what it looks like in game. Or actually, here, why don't we do this? I'm going to close this. We'll run. So the rivers are currently set up. Let me load the game to show scale. Because these are not, I want to emphasize that these are not the real rivers. These are the rough path that a river would flow. Obviously, I'm not going to create straight 128 meter sections of river. They're going to flow with the land and the local terrain and so on. These are just to give it a plot, because to plot rivers that way from start to finish would take forever. I mean, like, nobody's going to wait an hour for the rivers to generate. So we rough them in with that sort of rough sampling, and then when it comes time to actually need to generate that area of terrain, we know there's a river about there, and so we find the best path with the local detailed terrain. I'm standing in a river. Where am I? Let me brighten this up so you guys can see it. Okay, so I'm at a river bend here, and but let's see where I am. I have a map I can pull up somewhere back here. There we go. So that's my favorite river. So we're somewhere in here. If I can actually warp to the mouth of the river. So if we mark, what are my marks? Long plain river head. Okay, so if we warp. Long Plain River head. Like, okay, so we're up here. That's in this map. We are right here. Let me zoom in a little bit so we can see better. So we're right here. Each of these lengths is 128 meters, and you'll see we go a little bit, and we'll start to go. We'll find a place where it goes a little bit uphill. That one would be easy to deal with. So we got this little river. We're shooting ahead super fast. So we're still good. We're still good. And yeah, so we drop down. That's fine. I'm hoping to show a place where it. Yeah, so we didn't go uphill. Here's the red area up here. Like, I'm walking super fast, by the way. We're doing like 25 meters a second. So here's a place where it had to go uphill, and it goes uphill quite severely. And I can't just carve out. I'll explain why. There's sort of a fundamental issue with that. So we go over here, and then it's going to make a bank to the right. Yeah. So, and up here is a case where it raised the ground. So this is a case where it would have been too tall, but the river code raised the ground around this river so that it wouldn't just be floating in midair. It's doing it in a really aggressive way. There's a sort of more natural way. I want to do something similar for the canyons that it carves to make them smoother. But anyway, this is sort of the scale we're looking at. These are super straight, boring rivers, but we can already see if we flow up here, this river would have potentially flowed down a different way and still made it to where it's going, and it wouldn't have had to raise the land. It could have carved in and ended up where it was supposed to go. And so what I've been doing is tweaking that algorithm that cheats, how it deals with the cheating. Come on. And this is one of the places I'm going to be working on this weekend, which is great around blockhead. So I created some scripts that will allow me to play with like some terrain just in the blockhead and carve some rivers out of it. This blockhead tool turns out to be super useful. So if we come over here, well, let's see. So I have some scripts made. If I just do this, it'll just generate some terrain for me to play with. And so we can see we've got a little hill and a little valley. What happens if we cut a river from here to here? It's got to cut a valley here. It's going to have to cut through the valley here and raise the land over here. And so if we execute that script, that's what it does. So it cut a gorge here and raised the land to either side of the river here so that it wasn't floating in the middle of the air. And so tweaking this algorithm and making sure that the influence, let's go. So like if I set, so the influence is the radius of the river, how it affects the terrain. So if we set this to 1 and execute this script again, it's going to make super ridiculous river. Basically the ground came up to meet it, but it wasn't wide enough to actually contain the river. Because it needs to be wider than the radius, I think, at least. So if we do execute this again, yeah. So now we've got at least one little border on the river, but if we change it to something like 16, we get much more reasonable sort of thing. And again, a standard river will never generate a river section this long, not a straight one. It would probably have meandered, and so then the terrain would have meandered and so on. I want to do something similar to the way I've sloped the land when there's these deep gorges like this and the river's particularly wide. I want to be able to say, influence that to make a river valley instead of these gorges, and maybe make that random. I don't know. So this is not really a problem for local terrain that needs to be worked around. The river algorithm that cuts them into the ground, will figure it out and make it work. But the problem is cases where if we started going straight downhill from where we were, we end up with too much area to recover, and we cut through the whole. And so we end up carving a gorge all the way to the ocean, and that's not really what we want either. Let me see. I have a picture. So if we imagine this is like a side view of the river flow, these kind of things, here, that's a lot of carving to do. Here, this is, a little uphill, no big deal, right? We could carve a little gorge in there, a little valley, no big deal. This local terrain would have fixed it. These are just the sample points we did. Local terrain would have said, no, I need to flow down here. Where we end up with problems is this dip here is lower than most of this area of the river, and this is a really long distance away. So you almost need to start at this end and work your way back and make sure that the bulk of your river only goes up, and that you don't have these long spans that are underneath the bulk surface of the river. And if you were going to have a place like that, that's where you would say, okay, cut it off. I'm making a lake here, and I'll have to cut this off too, because it would look silly to have a river source only 128 meters away from a lake that goes in a different direction. So you trim this river back, and you say, okay, well, we start a new river here, and it'll flow to the sea. And to meet my goals of transportation, that's probably fine, because chances are a town would form here, and you could say, well, there's merchants that would have a little seaport here, and they would work on transporting it to this little town over here, and make sure they still got down to the big port at the ocean. And so when we were looking at, I'm not going to have any time to do any development, just talk about it. That's probably okay. A lot of times these live streams are helping me frame the problem. You guys are my rubber ducks, right? Helping me frame the problem, and then I can be more productive over the weekend. So this is going to re-render our rivers, and I want to show you where I cheated, and then what the picture looks like if I change the cheating. So what I did was I said, so looking at our rivers again, let's go back over to this river, my favorite river. I mean, it's just the perfect example, right? There would probably be a mining town that would form here, mining town that would form here. They would both service this river all the way down to the ocean, a big seaport here. It's even a protected seaport because there's this little island. It's cool. But these red things are of concern, because there's always the chance that the river goes so low through some of these areas that the only way it could reach the ocean is to carve a canyon all the way. And where I cheat on that is when we're building the river size. Yeah. So here I've decided that if the elevation at the point of flow minus our previous elevation, it's not even the previous elevation, it's the head. Oh yeah, it's the previous elevation. Minus the previous elevation, if it's more than 1 meter, so if we're going uphill more than 1 meter, we reset that elevation, we let it do that. If I take this out and I make sure that we just, yeah, exactly right. I mean, wide canyon, wide raising of terrain, you just don't want to be crazy about it, because if you start at the point where the river exits out at the ocean, let me bring back my picture. So if you start out here and you make sure that the river never goes less than this, and so you'd have to raise this land up, and so you come up here, it never goes less than this, you'd have to raise all of this land up, and so you've got like this is a huge amount of space here. That's a 1, 2, 3, 4, 5. It's like, yeah, it's a lot of space. So you've got to make trade-offs, decide that's too much, we can't do it, and then play with the numbers. Here in this case, I'm going to take out my cheat. I'm trying to remember what this does. This tells me, yeah, always take the lowest of the two. So if we take this out and never cheat, we should see most of this river go red, basically. Or pink or something. Oh. No, that's not right. That's not right. Something's wrong. Total flow is wet. E. Flow elevation equals E. It's the minimum of whatever the last one was and our flow elevation. So we never go uphill. Yeah. I don't remember exactly how to undo my cheat, but I had cases where when I was maybe it was these rivers over here. I had cases where when I was following the river, I started at the head and the land around me went uphill and the river just kept going downhill. And eventually I got to points here where the land was so far above my head and didn't really come back to river level until I got to the sea. And that's not really what you want either. So there has to be some trade-off, and I apparently have messed up my visualization. But yeah, so these red, what it's supposed to be is I track the actual flow of the river and the theoretical flow of the river, and when they're different it's supposed to render it as red. And so I've done something wrong here. When the flow elevation when the elevation of the land is greater than the elevation of the river, we're supposed to render that in pink. Or we add a marker. Oh, we have done that. All of these pink, let's make them more obvious. Let's make them yellow. Big yellow warning flags. I spent a lot of time waiting on these renders. Yeah, so everywhere this is yellow is a place where the river went downhill below the terrain and never recovered until just, you see, all of these basically are carving canyons. Ever since we got, every bit of yellow here is carving a canyon because the level of the river went below the terrain and never came back up again until right near the ocean. And let's go check out our fun river. I think it may make it a little farther. Nope. I mean, it did a little farther. So it made it here. And if we, so basically it never went uphill, never allowed uphill travel. And I actually walked this river and counted the number of times it went uphill and downhill, and it doesn't actually resolve, yeah, until the very end, like right here. And so if it saved these rivers, if we go back and see, I should be able to remove the, start it over again. Hey, I made the beverage last the entire live stream, just about. Okay. It's gonna be a little slow because it's gotta generate all this terrain that I just deleted. Anyway, we're getting close. And so the other thing is, the algorithm I use to correct this problem, to detect my, basically, I have to work backwards from the sea. Instead of working forwards and figuring out how to carve the terrain, I have to work backwards from the sea and decide how badly I had to cheat to keep going. And so when I get to places like this, I know how far back to cull and what to do with here. And I have to mess with those parameters. But the other thing is, it starts to resemble the same work I would have to do to plot the river between these 2 points, right? The detailed river, not just the big long straight line, but the part that, you know, meanders. And so normally I think of rivers flowing from here, and then I plot the detailed river from here, but I'm thinking I might have to go backwards and plot the detailed river from the ocean, keeping track of sort of how bad things have gotten to the point where if it exceeds some threshold, I just cut it off, you know, let the river stop here, create a lake here, and then continue propagation up. That may be what I have to do. Okay, so yeah, see, already we're like way carved in. Where did we come from? Let's warp back to, let me make sure I got the name right. Long Plain Riverhead. Yep, okay. Oops, wrong button. Warp. Long Plain Riverhead. Man, this warp thing is awesome. We're loading in terrain, so it's going to be a little slow. The other thing is we've got lots of these raised plateaus, and those are always the slow ones, so it creates extra time to do that. Ties up the threads, generating that far terrain. That's in the lower right corner. You can see it's generating those tiles. When it's done with that one, I'm going to race ahead. So I'm only going to race ahead anyway. Alright, so here we're starting to carve into the terrain. Tree hype, yeah. So here we got to go down, that's fine. Go down. And this is where before the river went up. And now it just carves through and makes a bank to the right. That's our, this is us down here. We just hit this section and now we're banking to the right. But notice we're now way under the ground because we never recovered the amount we cheated. And if I continue on here, eventually we do recover that and get back to normal. Yeah, here we go. So coming up, we get back to kind of normal here. Yeah. So now we're back to normal. We had the land to come back to. Doink, doink, doink. The other thing is I need to make the rivers get wider when they're fed. Yeah, so now we gotta wait till that terrain tile catches up. But at least we have stuff to look at. Yeah, when you can see like the far terrain between the gaps in the trees, it's really effective. like a skybox you could walk to, which is what it's supposed to be. Okay, so where are we? We just continue straight down the path we are. We're right here. So we just continue straight, and we're going to hit another pine tree branches hanging over the river. The river. Okay, super fast. Super fast. Yeah, so now the river's widened out a bit. We're underground, or under the ground. We're good. And come around the turn. And now we're going to go under the canyon here. And I've got to wait for the train to catch up because I walked too fast. G-Tree, you're looking rather flat today. Come on, I'm trying to illustrate something. You gotta hurry up. Yeah, there we go. Hey, that's much better. Okay, so we're just a little below the ground now. This is not a bad, like a valley, you know, a river valley tapering off. That wouldn't be bad, especially this ground is really flat. That actually would work well here. Yeah, real life canoe trips, yeah. Well, that's the idea. These little rivers would be, you know, canoe, small boats. Okay, so we have another feeder here, which is why the river got wider. We're still underground. It's getting worse. If I had to carve a valley here, I could do it, but it's starting to get crazy. But that's the, I mean, but that is the solution. You're right, right? That's why I have that stuff in the blockhead tool, so that I can work out valleys without having to load Mythruna every time with a deleted world. See, we never really recover that land. We're always below where we would have liked to have been. Get a nice wide river. I also have to tweak the river algorithm a little bit, like it keeps the depth, tries to make wide shallow rivers, which is fine. I think it maybe goes a little too wide before it makes them deeper. I have to think about that a little bit. My own experience with rivers is that a river this wide actually would only be about 1 meter deep. And you definitely 100% would not want to try to stand up in it. River caves. Yeah, I do want river caves. So then that's a case where, if we flip back over to our picture, that's a case where, like, say this side of the mountain was lower, you could say, oh, you know, it's too expensive to carve a valley here. The river's still fairly thin. Let's just carve a cave. But this end of the cave would be higher than this end of the cave. And so that really doesn't work. You end up making a valley on the other side anyway. But that is one option, is if I'm coming up here and I come over the high mountain and I decide, oh, that's too tall to carve through. But you know what? This end is still higher than this end. I could cut a cave. That is, I definitely do want to do that. Caves are coming anyway, and so that caves are my immediate next thing after rivers. And so it would taper in nicely with what I'm working on. Let's see, so I can tell you, even based on that visualization we did, we'll never recover our height. It'll always be just a little low. And in this case, it would have worked okay. We probably just could have carved a wide valley, and it worked. And that, again, like I said, that's what I'll do anyway. This is a nice river because the error rate is rather shallow lake, undersurface out. Yeah. Again, that would work fine too. It's only when water has to go uphill that it's a little weird. At any rate. So yes, I'll end up carving valleys. That's the whole point of having ported the river code. Wow, I forget how much the ambient sound is until it stops. That was sort of the point of porting the river carving code into Blockhead as a script, so that I can play with it a little bit. Get a great stream. Okay, well, I'm about done anyway, so thanks, Adrian. So anyway, so I'll be playing with this. I'll be playing with the settings that, so I'll be playing with how this carves valleys, and I can regenerate terrain differently based on, I can add different fractals and things in here. So I'll be playing with this. I'll be playing with the thresholds for when I decide that this red is too red and cut the river off. And I think this one, since we just walked it, this is a good example because this is a river that actually would work. It never has to make the error too high, and so it would just carve wide valleys and be done. Some of these rivers, that's not the case. Their error rate is severe. I mean, this isn't real, so I can't tip it to see. Anyway, I apologize we didn't get to any coding, but hopefully you guys got a good explainer on the perils of river generation. I'm just going to cut it off here in a minute. Any questions before I wrap it up? I'll give that a beat because I know you guys are on delay. Going to run the thank you card. Thanks for watching. Sorry we didn't get to do much coding today, but hopefully it was educational on some level. Definitely helped frame my next steps. That one block down surface level is actually consistent with many of their smaller rivers. Yeah, I would probably allow that, actually. If it's only one below the surface, I'd probably allow that. I might, depending on the fractal or the type of ground, let it slope away one block. It's the 3, 4 meters, 6 meter deep ones that I worry about, especially when the river is really wide. If the river is only 3 blocks wide, I don't mind it cutting chasms. But when it starts to get, 20 meters wide, it feels weird that it would cut a chasm, because realistically that river would have overflowed its banks many times and eroded that land away, and you get like a wide river valley, where farming is good and stuff like that. So it's going to be a balancing act, and this is why I'm spending so much time on rivers, because it's important to get them right. They're going to be the central focus of so many other things. Travel, trade routes, where towns form, all that other stuff. They're critical for that. So it's important that I get it right. And there's a certain aspect to working on this that's appealing to me, because so far for the past 6-8 months, I pull a task off the backlog and I work it, and then pull another task off the backlog and I work it. I don't often get to finish one thing completely because I'm chipping away at 5 or 6 different things, like the AI, or chipping away at this thing. And so rivers, I've decided I'm just going to kind of work them to completion, and it may take me the rest of February to do that. And if I finish rivers in February, I'd actually be really happy about that. It'd be one major thing done, and a lot of other stuff falls out from that. The complexity of having rivers flow across tiles into the other tiles is the most complicated type of cross-tile stuff I'll ever have to do. So caves become easier, roads become easier, town mappings become easier once rivers are done. So anyway, like, comment, subscribe, share with your friends, and I guess I will see you guys next time. Thanks for joining. It's been a lively session. See you guys next week.